Kia ora, Year 11, 12 and 13. This is question 4a from last year's scholarship calc paper. And this is really a warm-up question about logs, but it's again got some useful stuff in it that you might need to use for harder problems. So I'm going to go quite slowly through it. We have to find the values of x for which this equation is true. So just looking first at what we've got, the reason we know it's not going to be too bad is we've got log to base 3 here and we've got log to base 3 here. So it looks like what we're going to do is apply our log rules from level 2 and then solve. A couple of things we have to watch out for though is that whenever I've got a log of an argument, then I have to make sure that this is strictly positive. Okay, so let's look at why that is. Well, let's start with the graph of 2 to the power of x. We can see that 2 to the power of x is never equal to 0, and it's negative, never negative. That means that when I take the inverse, which is all the log function is, and I get log to base 2 of x, I can never have this number being negative or 0. Right? So here, x must be strictly greater than 0. So what does that mean for our problem here? Well, we've got two conditions that we're going to impose before we even start to muck around with the log expression. So we must have 4 minus 2x strictly greater than 0 and x strictly greater than 0. So let's clean those up now. We've got negative 2x is greater than negative 4 or x less than 2. Here we've got x greater than 0. So both of these things have to be true. So from the start we can see that x has got to be between 0 and 2. Now that we've done that, we're going to work on cleaning up the left-hand side, and then we're going to undo the logs on both sides. So we're starting from here, and we're going to turn that into the log of a product. Now we're going to undo the log, which won't cause any problems for my inequality sign because all I'm doing here is I'm going 3 to the power of on both sides. Or if you like thinking about the loopy thing, I'm going 3 squared equals blah, 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 only I'm not going equals because I'm working with an equation. So what I've got here is I've got 4x minus 2x squared is less than or equal to 3 squared, which is 9. So we're solving a quadratic inequality. Negative 2x squared plus 4x minus 9 is less than or equal to 0. Multiplying that through so that I don't have a negative coefficient on the x squared gives me this. And now I want to figure out when this is strictly positive. Now you could do this using the quadratic formula, or you could try and factorize it, whatever you want to do. But I'm going to do completing the square on this. So I get 2 into x squared minus 2x plus 9. I did warn you I was going to go pretty slowly. So here we go. So I'm going to take out the 2, add 9, and that's what I've got. If you're wobbly on this, please go and watch one of the level 2 completing the square videos. Right, so we want to figure out when this is true. But 2 times x minus 1 squared is greater than or equal to 0 for any value of x, right? The lowest it'll be is when x is 1. So 2 into x minus 1 squared plus 7 is greater than or equal to 7 for any x. So what does that leave me with? Well, I'm back to the conditions that I worked out right at the start, which is this thing here. So that's my final answer. So all of that work in the middle turned out to be for nothing. X must be between 0 and 2 for the inequation to hold. Thanks for watching. As usual, leave me a comment if you've got trouble with any of that, or send me an email. And if you don't know my email, leave me a comment and I will let you know what the email is.